Hi and Assalamualaikum. We are Group of 5 from CS143-4B. Our group consists of 5 members. First, Julia Rizkita binti Azmin. Second, Nur Akilah binti Yahya. Third, Nur Anira binti Shamsul Jahari. Fourth, Nurliana Iman binti Zulfikar. And last but not least is Siti Nurul Najiha binti Khairul Huslaini. In this video, we will be presenting a case study about a system of linear equations and determinants.
Next, let's move to the introduction of our case study. First of all, what is linear algebra? Linear algebra is a branch of mathematics that is concerned with mathematical structure close under the operation of addition and scalar multiplication, and that includes the theory of system of linear equation, metric, determinant, vector spaces, and linear transformation. Techniques from linear algebra are also used in engineering, computer science, and others. If we study about linear algebra, of course, we learn about metric. In mathematics, we normally talk about numbers. So informally, we can define a metric as a set of numbers arranged in rows and columns so as to form a rectangular array. There are a few examples of metric are as follows. There are many types of metric. For example, triangular metric, diagonal metric, identity metric, zero metric, column metric, and row metric, and others. One of the main topics in linear algebra is the study of system of linear equation. System of linear equation is usually a set of two linear equations with two variables, x and y or others. How we want to determine which of the equations are linear equation? Firstly, linear equation cannot involve product of two variables. Secondly, linear equation cannot involve trigonometric function. Next, the most important method to solve system of linear equation. First of all, we need to do augmented matrix, and it is normally used to represent a system of linear equation. And this is how augmented matrix looks like. Last but not least, determinant. A determinant is a unique real number associated with a square matrix. Matrices which are not square matrix do not have a determinant. The value of the determinant gives important information about the matrix. The determinant is denoted by determinant of A or determinant of A in the bracket. There are several methods to evaluate determinant, and we will discuss it later on the next slide.
Next, purpose of study. First, to recognize a linear equation. Next, to find a solution set for linear equation represented parametrically. And lastly, to recognize and find the determinants.
And here is the case study. A group of friends went to Pasar Tani on Sunday morning. There's a lot of entrepreneurs selling raw food such as fruits, vegetables, and meat. Nelly, Atir, and Rania spent 65 ringgit, 54 ringgit, and 55 ringgit respectively. Nelly bought 5 kilogram chicken meat, 1 kilogram green vegetables, and 2 kilogram fish, while Rania bought 2 kilogram fish, 1 kilogram green vegetables, and 4 kilogram chicken meat. Same goes to Atir, who spent the least at Pasar Tani. She bought 2 kilogram green vegetables, 3 kilogram fish, and 3 kilogram chicken meat.
First, we go to question 1. Form an augmented matrix that represents the system of linear equation. Okay, firstly, we need to take out all the information inside the question to create linear equations. After we have the linear equation, we can form an augmented matrix. So, this is how you form an augmented matrix.
Question 2. Question 2. We are required to find the price of chicken meat, green vegetables, fish per kilogram by using the Cramer's rule. First, we have the matrix of 5, 1, 2, 3, 2, 3, 4, 1, 2. To do the Cramer's rule, we have to copy the matrix and rewrite the first two columns on the right hand side, which will result the matrix shown. Next, we have to multiply the value on the diagonal from top left to the bottom right, and the product will be added together. As the calculated value, we got A equal to 1. Next, we have to find A1, which will be our chicken meat. So, for A1, we have to do the Cramer's rule, and we will get 10. Then, we have to find the value of A2, which will be our green vegetables, and we will get the value of 3. Lastly, we have to find the value of A3 by using the Cramer's rule, which we will get the value of 6. The last step to do is we have to divide the value of A1, A2 and A3 to the value of A. For X, we will get equal 10. For Y, we will get A2 equal to 3. And for Z, we will get A3 equal to 6. So, the chicken meat price, the price for chicken meat is 10 ringgit. Green vegetables will be 3 ringgit. And the price of fish will be 6 ringgit.
Question 3. Find the inverse to the matrix if it exists. To solve inverse question, there are two methods that we can use. The first one is by using formula and the second one is by using elementary row operation. If we want to use formula to find inverse, it can be used on square matrix of any size only. So for this question, I'm using elementary row operation. First one, write the matrix A on the left side and the identity matrix on the right side. Separate these two matrices by a straight line. Secondly, use Gauss Jordan elimination method to reduce A to a reduced row echelon matrix. Whatever elementary row operation that are performed on matrix A are also performed on the matrix identity on the right hand side of the matrix. We just follow the second step until we get the last answer, until we get the left hand side identity matrix. If A can be reduced to identity, then the matrix that you get on the right side is inverse of A. If A cannot be reduced to identity, then the reduced matrix will contain at least one zero row and thus A is not invertible. So our answer for this question is provided in the video that I'm circled in this slide.
Next is question 4. Evaluate the determinant of the following matrices by using cofactor expansion along the row indicated. So the question 1 is to expand along the second row. To expand along the second row, we go across the elements in row 2. The first term is negative 1 to the power of the row index plus the column index of the first element, which is 2 plus 1, times with the element 3 times the determinant of the submatrix formed from deleting row 2 and column 1, plus the second term is negative 1 to the power of the row index plus the column index of the second element times with the element 2 times with the determinant of the matrix formed by deleting row 2 and column 2. Plus the third term is negative 1 to the power of the row index plus the column index of the third element times with the element 3 times the determinant of the matrix formed by deleting row 2 and column 3. Now we are going to expand those 2 by 2 determinants. Negative 3 times the determinant 2 minus 2 plus 2 times the determinant 10 minus 8 plus negative 3 times the determinant 5 minus 4, and simplifying this gives us the answer determinant A equals to 1.
Next, we move to question 5, which asks us to evaluate the determinants from your answer that you got from question 3 by using series rule. So from question 3, we have got the inverse of the matrix, and as we know, to find the determinant using series rule is S1 minus S2. As you see on the slide, I have provided the formula to find S1 and S2. Before we apply S1 and S2 into the matrix, we need to take out the first column and the second column of the matrices into the right side next to the column 3, and it will be 5 column with 3 rows. Using the formula or the arrows that I have shows in the slide, we can find the value of S1 and S2. So for S1, we have 1 times 2 times 7 plus 0 times negative 9 times negative 5 plus negative 1 times 6 times negative 1, and as define the answer for S1, we will get 20. And for S2, we have negative 5 times 2 times negative 1 plus negative 1 times negative 9 times 1 plus 7 times 6 times 0, and we will get 19. And to get the determinant using the series rule, we need to apply the formula that I have shown in the slide, which is S1 minus S2. So when we apply here, we will get determinant of A inverse is S1 minus S2, which is 20 minus 19, and as the final answer, we will get the determinant of the inverse is 1.
Okay, we move to the last question, which is question 6. For the system of linear equation, based on the case study, state the leading variable and free variable. So how we want to find the leading variable and free variable? We will use Gaussian elimination method. So we solve it using elementary row operation until we get all the leading one and zero value placed at the bottom and above the leading one. Since every row have leading one, we can conclude that x, y, and z are leading variable. So there is no free variable in this equation. As we know, this system of linear equation has unique solution. Then the system of linear equation is consistent.
So for the conclusion, we use algebra quite often in daily life without even realizing it. Most of our problems that involve calculations can be solved using algebra. For instance, in this case study, we could find the price of chicken meat, green vegetables, and fish per kilogram by applying Cramer's rule. That's all from us. Thanks for watching.